Okay, let's implement time attention together. First of all, we're going to get the shape of decoder hidden state like this. And we're going to gather the output. And to do so, we first create empty array like this. And a list for collecting layers. And a list for collecting attention weights. And for capital T range, we're going to create an attention layer like this. And for each time step, we calculate context vector. And to our layers, we append the current layer. And to our attention weights, we append the layers, attention weight like this. And then we return out. This is pretty simple. And for backward, we also get the shape of the out. And this is first 0. And for T in range capital T, we need to go in the reverse order. We first retrieve the last layer. And call the backward method. And add this upstream gradient. And for the current time step, we collect DH and return DHS encoder, DHS decoder like this. Okay, this is how we implement time attention. Then, using these time attention and other things, we're going to implement attention sequence to sequence. And for this, we're going to inherit the ordinary sequence to sequence. Basically, every other functionality is the same. The only thing we need to change is what decoder block we are going to use. That's all. So it's pretty simple to implement attention sequence to sequence interface. The only thing we need to implement is the initializer. Okay. And then we're going to define attention encoder by inheriting the ordinary encoder we've already implemented. In this case, we just need to implement forward, backward. And we need to change quite a lot for the attention decoder. Forward, XS, and encoder, HS. And for backward, D-score, like this. Okay, let's implement the initializer of the attention sequence class. The arguments are vocab size, word back size, hidden size. Then we're going to define the encoder first. We're going to use attention encoder. And we're going to pass args like this. And then we're going to implement decoder. You just need to call attention decoder. That's all. And we need to have softmax. However, here we need time softmax. Self params, encoders, params, decoders, params. We also collect grads, grads, grads. Then we're done for attention sequence to sequence. Quite simple. And then we're going to implement attention encoder. This is also very simple. We pass through embedding layer first and pass through LSTM. Then we return these hidden states. And for backward, we pass through LSTM first. And then embedding layer. And then we return the out. For attention decoder, we need to change quite a lot. Let's see what we need to define differently. Up to this point, pretty much same. Define the embedding weight and normalize. LSTM weight, WX, D 4 times H. LSTM W, H, H times 4 times H. And normalize LSTM bias. And we also need to define a fine layer. And a fine bias. Then we need to actually define the layers. The first one is embedding layer. And we need to define time embedding. Then we need to define LSTM, time LSTM. And then here, we need to define the attention, which is time attention. And define a fine W, a fine bias. And our layers are self-embed, self-LSTM, self-tension, and self-affine. Params and self-grads, empty lists for layer, layers, collect layers parameters like this, and gradient as well. Okay. How we're going to implement forward and backward is like this. We're going to first pass these inputs through this embedding layer. And then we pass through LSTM layer. Then we pass through attention, then get context vector and concatenate the hidden states from this LSTM layer, which is decoding hidden states. Then we pass those concatenated values through this affine layer. Okay, so embedding layer first, LSTM layer, then we are going to calculate context vector using this attention layer and concatenate context vectors with hidden states of decoders. Then we go through affine layer. Okay, that's how we are going to implement attention in this case. Think about how we can implement those schemes using these forward and backward. All right, do it on your own and see you in the next video.